Okay, we can start now. We're recording the talks and we'll upload them later, today, tomorrow, probably this week. And the first topic is how to shoot yourself in the foot expertly. And to do that, of course, you need a foot gun. This is the definition from Urban Dictionary. So it's a great tool to shoot yourself in the foot or to leave it behind in the code so someone else a bit later can shoot themselves in the foot or even future you. So it's great. One foot gun which is really easy to leave behind is not specifying the orientation of linear layout. So we have simple linear layout. It has a label, and we intend to programmatically add more items vertically into this layout. But yeah, the default is horizontal, so we're gonna spend some time debugging. Of course, the fix is to add vertical. Nothing fancy here. Something a little more subtle. This is a class which represents a model which we get from the network. So a network call returns a JSON. We deserialize the JSON into this object. Can anyone tell me what could possibly go wrong here? Yes? No? I'll give you a little hint. It has to do with ProGuard. Yes? Yeah. So when you use ProGuard, it will, by default, it will change all the names, and most libraries for deserialization rely on the names of the fields, and they use reflection to read them from the JSON and to fill your model. I know Jackson works that way, JSON, and also Moshi from Square. So the fix is, of course, to add explicitly the names. This is for Moshi. For JSON, it's serialized name, and for Jackson, it's, I think, serialized JSON property, something like that. So it's a really nice foot gun because it can be very subtle. If you have a class which represents a location, for instance, you have two integers inside, longitude and latitude, and it's an integer, a primitive type. By default, it will be 0. So all your locations on the map will be at 0, 0, 0. So it's a nice way to spend half an hour debugging. One more. Have you ever done this? Please raise your hand if you've ever done this in your life. So you have a staging API. Yes, 1, 2, 3. Good. Good. And then you rely on your fragile human mind to remember at some point that this needs to be uncommented, and possibly before you ship it to the client to test with the production API. Yeah. So don't do that. I'm fairly certain you don't do that anymore because we have Gradle. So you can use Gradle to generate different constants based on your build type, on your flavor, and so on. You probably already know everything about that, so I won't talk about that. But still, it's a nice foot gun. One more. So this, maybe it's a bit obvious also, but this is a navigation menu from the design support library. It has a nice way to define the items in the XML. So each item has an ID. And well, you can leave this foot gun for someone else in the future, so they can, when the specification changes and you need to add a new item in the menu at the first place, they'll think, yeah, sure, I'll just edit the XML and I'll be done with it. But yeah, the indexes will change because someone didn't use the IDs, and yeah, you get the point. The fix is to, of course, use the IDs, and then you also don't need this comment because it's obvious what it does. So when are foot guns okay? Foot guns are okay if you you're in such a rush that you deploy the build that customers' phones are literally setting themselves on fire, then maybe they're okay. Otherwise, don't do it. Any questions? No questions at all.
Why do you use like serial as name for JSON instead of just specifying product rules?
I think it's more robust. So you can't just copy your model into another project and forget to add program rules. Yeah. Anybody else? Thank you.
Neće se ugasiti, jel? Lijevo desno.
It's all yours.
Thank
Lijevo
you.
desno i ovaj termin pointer.
Okay, hi everybody. My name is Anna. I'll be saying a few things about app links, which you probably know something about. This is just a quick overview of some functionalities which were brought in Android M. So the topics today is basically what is app linking, what are the prerequisites for you to implement it, and some items under the hood which you might find interesting. So, how many of you have clicked on a link on your smartphone and have gotten this here dialog open with? How many of you were annoyed by it? Okay. Well, basically, Android M introduced something awesome, and that's app linking, which basically allows you two things. You can associate an application with the web domain you potentially own, or maybe somebody you know owns, and you eliminate those pesky open with dialogs if you want to. So it's basically a good user experience, which you can provide for your users. So what do you need to accomplish this? You need a permission to put some files in the root directory of your web server. Or you need permission to access the server from your client or whatever, because you will be needing that to configure something. You will need to put a specific JSON file in the root of every domain you wish to link your app with. The file is basically simple. It should be placed in the root of your domain server, in this folder here, and it should be called assetslink.json. Seems simple enough. Just one JSON file. Sorry? For your application, you just need two things. You need to set the compile SDK version to 23, because this feature was introduced in Android M. And you need this little tag here to be placed in every intent filter that holds a data tag. Basically, you'll be implementing automatic verification of your application as soon as it is installed, but a little more about that later. So how do we do this? You need to do three things. Create intent filters. So basically you can say in your manifest what activity will respond to a specific URL. You need to define its scheme, its host, and a few other things. You will need to configure each of those intent filters with a tag, which we already mentioned, and you will need to publish that JSON file to the server which you want to link to. So how do we do this? It's fairly simple. You've already seen this. You will need to define some kind of activity that will respond to the action you've clicked on. It needs to have a few things. The scheme, you can use HTTP, HTTPS, both, but only these. If you say that the scheme is market, it will not be fired when you try to verify the data. Another thing is that it needs to have the action view and category browsable, which means it will respond to the link. So, after this criteria has been met, here comes the tag. This is I'm sorry, this is just the example of what I just mentioned. So we have the intent action view, browsable, and we want our activity to fire on HTTP and HTTPS for this concrete server. So, the configuration file. This is what does all the magic. So you could have done all that even before. You could have linked your app to respond to certain URLs, but you could not guarantee that only your app will be opened. So for us to take care of this, you will need to place a file containing JSON objects, which have a very specific structure. So most of these things are not to be modified. What you need to do is place your package name, regardless of how many they are. You can place many objects inside for each one of your applications, if they differ. And you will need to place fingerprints, SCOP 256 fingerprints for your application. Let's say that you have a few flavors for your app, and each has the same application ID. You have different key stores which you sign your application with. You can take care of that very easily by placing here a list of those fingerprints, and everything will work. So as we said, a JSON object for each application ID you want to verify. This is how you get those fingerprints, and you're good to go. So another thing you might want to know is about the verification process. The documentation states it happens only once, when you install the app. And by saying that, it also means each time you reinstall the app. You have the package manager, which basically takes care of our APK. It verifies that it's okay, that it can be installed. And you have the intent filter verifier, which is new. And its sole purpose is to take care of the verification. So it will look at your manifest, take care of the data inside, and try to contact the server and ask, okay, for all those domains you listed, let's see if they do have a JSON file in their root, in the directory we already said. So we can say, okay, this app truly will launch and is supposed to launch when we click on a specific link. The downside is that it needs to establish a connection within 5 seconds or the verification will fail. Which means the next time you'll get a chance to do the verification is when you reinstall or update the app. What else? The documentation states that you should really test this, and it's kind of a big deal, as with everything in the apps, because you want your users to have the best user experience. That means, okay, my app will open Facebook, and you really want it to open the Facebook app. Facebook links. You don't want it to show the dialog, and basically those 3 things that are listed here are the ones to test. You should make a list of your hosts, each one you stated in the manifest, and check that they are linked to a specific JSON file. You should confirm that the files are okay. That means they hold the right fingerprints, that they link to a specific application ID, and you have the API here, so you can test it from your terminal or console or whatever. So testing is not the problem here. And another thing you can test is the URI intent, which basically lets you start the app from the terminal again. So not a lot of different information here, maybe just an upgrade from the existing intent system we already have, but this little difference can make a big difference in the eyes of your consumers. So let's keep them happy. Before I say thank you, I just want to say that although this is a great step towards user experience, you can always change this behavior in the settings. So this is, in my opinion, a great way to do things, because you improve something, you give your users an ability to use it, but you also give them an option to change that if they wish. So this is basically all for me today. There are some links in the end, and you can check for more information if you wish. Thank you. questions, I would like to ask.
What about the security when accessing the root folder of the domain?
Well, you have to have access to it. You as a developer must be able to upload a file to it. It has to be accessed via HTTPS. So in the second preview of the Android M, you could have accessed it through HTTP, but in the final release they switched to HTTPS. So even if you say that your server is available through HTTP and HTTPS, the verification will be done solely through HTTPS. So that's about it. Yes?
And what about extracting parameters from the links you click on? Let's say there is a service called branch that allows you to specify, like you create a link, and then if you click that link from, let's say, Chrome browser on your mobile phone, it will allow you to open your app. And also it gives you an option to add some parameters. I don't know.
That's something, yes.
Is there something like that in this?
We already had that before. You could have sent parameters through a registered schema through the Android manifest. This introduction was solely to enable you to say that your app is exclusively registered to a specific server. So the functionality which you mentioned remains. You can still send parameters. You can define, I don't know, you open a bank application which has been registered to the server, and you send a transaction ID. And this functionality which you just mentioned, you can parse the parameters from the URI, and you can still open a transaction screen with that parameter. So that's still okay. It still works. This is just added benefit so that, I don't know, XY app doesn't try to open that transaction ID by itself if it registered the same schema in its own manifest. So nothing has changed in that regard. Anything else?
So in the old system, when dialog pops up and you have to choose your own application, let's say, and you always use that, you practically same as this, but without the first
Yes.
one.
Yes. So this is just trying to leave that pesky dialog out of the user's hands. Okay, we're smarter. We just know that this application will be linked, and let's not bother him. Anything else? Okay, I'm not seeing any more hands, so if that's it, I would like to ask my colleague Kristijan to come here and amaze me with his retrofit knowledge.
We shall see. Have the floor.
Hi everyone, my name is Kristijan. I'll be talking about upgrade of Retrofit to 2.0. Has any of you ever used Retrofit? Yay. Anyone tried Retrofit 2? Okay, cool. Well, this is a major upgrade. So let's start by saying what is Retrofit. 1 second. Okay. So Retrofit is a HTTP networking library. It is made by Square. It turns your HTTP API into an interface, and it allows you to pass parameters and use its serialization to map the response into some POJOs. So, okay. So for usage, you just have to add one line to dependencies in your BUILD.GRADLE. That is this one. You will notice that Retrofit is still in beta, but it's perfectly safe to use it in production since the API will not change. For all new projects, we already started it. So what's different in relation to Retrofit 1? Well, first is package name. Package name is not Retrofit, but Retrofit 2 now. Converters are not part of the Retrofit project package anymore. They are separated, and you have to include them as dependencies in your BUILD.GRADLE. Also, service method returns call will not let you specify if the call is synchronous or asynchronous in your service or interface, but instead each method will return call or observable if you are using Herix for development. Also, HTTP client is required. It actually pulls retrofit dependency actually pulls OKHTTP and OKIO. If you want to use different version of HTTP, then you have to exclude this one from the retrofit dependency and include the version that you want. The difference is also that you need manifest internet permission, otherwise it will throw a security exception. And at the end, you need, it's renamed from REST adapter to Retrofit class. So, more about call. Call is a new object. If you ever used just plain OKHTTP, you would know about it because they use the same pattern. And call to specify synchronous or asynchronous requests. Now use enqueue for async requests, in which you will pass the callback with POJO which you want to be returned. Or you can use execute if you want to make synchronous call. In that way, if you call execute, you will get the object as a return value. Also, there is a new functionality which is cancel. It allows you to cancel the request, and you have clone, so you can retry the request if it fails for some reason. The big main difference in Retrofit is that if a response is returned, you will get everything in onResponse method in your callback instead of onFailure if it fails. OnFailure will only be called if there is some exception, like, I don't know, JSON failed to convert your response into POJO. OnResponse now handles many things. So it's used for async calls, and you have to check if your response was successful. You also have helper methods like which status code it will return, and also you can get the body of the request and error body in the onResponse method. Next thing is URL handling. URL handling is a bit different than Retrofit 1. So it's handled the same way as a graph parameter in web development. That means if you have annotation like this and base URL like this, it will replace the last one. So instead of v1, you will get blog because the base URL is not with ending slash. So if you have, for example, this is the result. So if you have, for example, base URL which ends with slash, then this will be your result. There's also a thing that you can put, for example, backslash here, / here, but in that case, it will behave somewhat differently, and your base URL result will be this will be replaced and blog will be put. Like this is root of your domain name. You can also put the whole URL into the get, and also now Retrofit supports dynamic URLs. So that means you can specify, for example, annotation and pass in the whole URL as a parameter. So new thing is also log, which doesn't exist anymore. You can, for instance, do it in OKHTTP as interceptor, or you can use Stato from Facebook, which is a third-party library, and inspect your responses in Chrome. So converters. Converters are, as I mentioned, in different packages. You can include them, you can set them on Retrofit Builder, and you can include them in your build dependency depending on which one you are using. You can also create your own by implementing factory method, factory interface. And this, I won't explain how this is done, but adding the converter to Retrofit is something like this. Especially if you need some type converters, then you create new JSON object and you pass it in as parameter to converter factory. So that's it. Any questions? Yes?
Does Retrofit 2 break your lint?
What?
Does Retrofit 2 break your linter? Because when I tried using Retrofit 2,
Yeah.
I got a lint error because it seems to reference something from JDK, which is the best in Android.
I haven't received that error, so I'm not sure. And we are using static analysis for linked BMD find bugs, so it didn't record anything. Yeah.
Are there any performance differences between?
Well, no. Retrofit is much smaller. Retrofit 2 is much smaller library than Retrofit 1, and it basically delegates everything to OK HTTP, so it can be only faster. Anything else? Okay, well, that's it. Yeah.
So enterprise app development,
Something like that, yeah.
just have to full screen it.
No spoilers, please.
Yes, no spoilers. Okay, why is it so small? Okay.
Hi everyone, I'm Blaž. I come from a company named Kamino from Slovenia. We are a young company founded this year that specializes in mobile development. We do Android, iOS, and Windows Phone. I am a head of Android developer there, and today I want to talk to you about enterprise app development with Samsung. I'm not in any way correlated with Samsung. They're not paying me to talk about this, so don't worry about that. Why I want to talk about enterprise app development with you guys is I think it's a very interesting topic that not much developers have opportunity or are interested in checking out. And I just want to give you an introduction of a quick overview of what Google is doing in this part and some intro in what Samsung is doing, which is kind of okay. Let's say that. So at the moment, animations are gone. At the moment, if you want to develop for enterprise applications on like stock Android, the only thing you have is Android for work. This basically first part of this is managed profile that was introduced recently, and this basically gives firms like companies possibility that they have phones dedicated for work. So if you have a phone that you brought from home, you can have business apps in there, and they're totally separated under different user on your phone. How they did this is pretty simple. So every application on Android is a separate user, and it's a separate user ID on Linux level. And basically, what Google did is just add the user from Android ID to it, and then you can have multiple installs of the same app on your device, accessed by different Android users on your device. This is really great solution because you still preserve the sandboxing and stuff that Android provides you out of the box. So that was added in Android 5.0 or something like that. What has been around quite a while now is device administration. That's this part here. You've probably seen it. These are here listed. The one with the checkbox have like additional permissions on your system. They can do some stuff that normal applications can't do. Like they don't have permissions, but these guys here have it. You can always check that off, and the applications won't get those permissions anymore. The problem here is that this is very, very limited. If we check this, it's basically all the features that you can do with this. You can put on one slide with no problem. And if we look a bit closer, all of this is about passwords, and then you have request encrypted storage and disable camera. So basically, you can request that user has to enter a password and specify what kind of password when they unlock the device, and then you can encrypt storage and disable their camera. There are some other stuff, but basically that's your limitation if you are using pure Android as an enterprise solution. Let's talk about Samsung. What Samsung did is they took the stock Android, put a bunch of stuff in it, and deploy it to their devices. What this bunch of stuff is NOx. They call it NOx. This is basically enterprise solution for Android phones. And there I will glance through these 4 parts. There's NOx workspace that basically does pretty much the same thing that Android, that managed profile does on stock Android. Isolates your private and your work applications, adds some security to it, and that's basically it. A system administrator, like your company administrator, have some kind of dashboard that they can control your device. The next part is NOx framework. This is a bunch of APIs that Samsung adds to their system image when they deploy this to mobile devices, and they give you as a developer access to these things. You must register for enterprise development and stuff like that, but in general, every Samsung device, almost every Samsung device, has NOx framework in it, and you could be able to access it and do a bunch of great stuff. You may have heard of this because there was a rumor, or I guess announcement, for Android L that Samsung will be contributing NOx framework and security enhancement for Android into the Android open source project. At the end, this didn't happen. I think that Google guys just looked at the code and they were like, we're not putting this shit in it, so. Now we don't have NOx in every device. The third part is trusted boot. This basically is a really low-level solution that guarantees that Android is booted at runtime, that no one hooked into there and put some sort of different OS or something to get your data or something like that. So this is basically just at boot time, you can be sure that Android is booting and nothing else. And then security enhancements for Android, just some, I guess, security enhancements. There are a couple of different stuff there, but I won't talk about them. So since this didn't land into Android open source project, it's only available on Galaxy devices, except for Galaxy Nexus, which image is provided by Google. So every Galaxy device out there has this in it. And why is this important? Because if you look at the shares, it's a bit outdated, but anyways. Samsung has a pretty high pretty high share when it comes to mobile devices. I think it's below iOS now, but anyways, still pretty high. And if you want to develop for business customers, it's quite a big share. It's not the whole Android, but it's majority of it. So it still pays off to develop for it. So yeah, let's look a bit into Nox framework. What actually Nox is. Basically, you have Android OS, and then you have Android framework that you as the developer can use. And when you develop for Samsung, you have, besides the Android framework, you have Nox framework. So basically, you just have a bunch of APIs that you can use and take advantage of. Pretty much everything that Nox provides is done via system services. So everything that you will want to do, you first get system service via the binder, and then you have the instance and you can do stuff. It requires system level permissions, and we'll look a bit later into how they manage this. But yeah, if you're just a normal app, you don't have these permissions, and you won't be able to access it. So you need system level permissions. And for you to start developing, you basically just need to add add-on in your SDK folder. So if anyone looked into Android SDK folder, you have inside is a folder named add-ons. You just drop another folder in there and you're ready to go. Gradle will handle everything for you, compile it properly and so on. I listed a few frameworks here that I just glimpsed through the documentation and put a few interesting ones in. If you look password policies, this is basically in here is everything that we looked at back there for device administration stuff and a little bit more. And then you have, for example, application policies. Here you can play around with applications that users have installed on their devices. You can install new applications. You can disable, enable applications, delete applications, stuff like that. Of course, for everything that you do, you still need manifest permissions. So user that will install will still see that you will do something with it. I don't know, install apps and stuff like that. But in a corporate world, this is usually done by some sort of system administrator. So usually the end user won't see these permissions and requirements that your app wants to have. And yeah, then you have APN, Bluetooth, stuff like that. You can disable roaming, for example. LDAP and VPN are really popular for enterprise development. So, and the list goes on and on, and some really interesting stuff. Cool thing here is that basically everything that's in Nox, Android already supports, but it just don't. Android SDK just doesn't give you access to it. Again, because you need system level permissions. How did Samsung give you system level permissions? This was the old one. They've changed it, but I think this is a good solution, so I want to talk about it. At the beginning, that was like, I don't know, 3-4 years ago. Every app, so first you have this long onboarding process that Samsung verifies you that you're an OK developer, that you won't do shit and stuff like that. And then through that you got your SDK, you got everything to develop your app. And then for every time you publish to the Play Store, you send unsigned APK to Samsung in a manifest file. Samsung will review the manifest file, check that it doesn't contain anything sketchy and stuff. Mostly they check for security reasons. Every denial that we got regarding manifest file was security reasons. And yeah, if they confirm it, they will send you a signed APK back. Why this is important? So every Galaxy device out there that's not rooted has been signed by Samsung the same way you sign your APK before you deploy it. And every one of those devices has the same signature. And when you send your APK unsigned to Samsung, they will sign it with the same key. And when they sign it with the same key, Android system automatically gives you system level permissions. So basically, when you get that APK signed, you're on a level like the APK was installed with the OS together. And this is basically as secure as it can get. You take advantage of Android built-in security systems, and you can pretty much guarantee that it will work. It will be secure from the outside and stuff like that. When we develop in this way, you had to develop on emulator. So in add-on that Samsung provided for developers, there was an emulator image, again signed with the same certificate, the same signature. So this would work on it. That emulator also had Knox implementation in it. And besides that, you got two system images for two specific devices. So you could only test on two specific devices, like on a hardware. You had two devices, decide which one you want, they send you the images, you root the device, set it up, and you had, in your development process, those two devices that you could test on, nothing more. Again, of course, when you send the application to Samsung for signing, when you got it back signed, you could use it on every device because it has the same signature, and eventually it will go to the Play Store. So yeah, the main limitation was this: only two hardware devices that you could test on. New way. So Samsung decided that they don't want to sign APKs for you anymore, because I guess it takes time. So they introduced something called MDM. What MDM does is that you have to handle in your application when you start it, when you need these permissions, you need to call some Samsung APIs or SDKs. These SDKs make backend requests, which is a problem if you don't have a network connection. And we'll retrieve some tokens and store it to the device. If you're a bit clever and play around with this Knox SDK, you can fairly quickly find where this token is stored. So it's not as secure as it was. Still, American government approved it, so you can use it for American military without a problem. And yeah, you got the token on your drive, no problem for accessing it. When they introduced MDM, they didn't provide support for emulators. We were in contact with Samsung and they said that it's not secure for them to provide emulator image, so you don't have emulators anymore. But the benefit is that you can run on every hardware device, any Galaxy device out there. Because again, signature is not important anymore. You do MDM activation, and they approve it on the back end, so you have permissions. What this does is, if you look at the documentation for Knox, you have some methods, and they said, okay, you require this manifest permission to do this, and since MDM, that's not always correct. Sometimes you just leave the permission out and it will still work. So it's gone from really good, except for this, to so-so. Okay, let's look at the code of it. I'll just glimpse through it, nothing in detail. So first thing when you develop, you need to add an add-on that Samsung will send you. Just copy the folder you get into this folder on your system, and then you don't use compile SDK version anymore, but you use this string. This is Android level, SDK level, and this is Nox part or NPM part. You just change this. This will tell Gradle to look into this folder that you provide here and grab a couple of jars from it and compile it in your build, or for your IDE to use, so you can have auto completion. Otherwise, it's not much happening here. First thing, after that, of course, you still need device administration. So you still need to be device admin in order to work with Nox functionalities. So basically, you put a receiver in your app that will call you. The system will call you. You can pop up some notifications for user what will happen at this point, and that's it. Here you can specify the device admin permission that Android provides, but you're not using it, so it's just an empty XML file. Next thing, when your user enters the app, you have to act as the user to allow you to have device admin permissions. You do this with a simple intent. This is the receiver you provided in the manifest, and start activity for result. On activity response, you will get success or failure, or result okay or result cancel. User will see something like this. So they will see a list of permissions that you will be using, and they can either cancel or activate. When you activate the device administration part that we saw at the beginning, the photo will have the checkbox checked. After you've activated the device administration, you can do the ELM activation, Enterprise License Manager. This is the part that will make a backend call to Samsung and confirm that you have permission to do stuff to your OS. Like you get an Enterprise License Manager instance. That's basically system servers. You could call context get system servers, Enterprise License servers, and you will get the same thing back. And then you just make one call. This is a token that Samsung will provide you, and you just hard code it in and hope no one decompiles your app and checks it out. And then you have this awesome Samsung API, and you have to register a broadcast receiver that will call you back when the ELM activation is done. Here you'll get whether it succeeded or not, and then handle it appropriately. It has happened that this callback was never called, so not as reliable. After you've done this, and this is the UI that user will see. So bunch of privacy and license stuff, check the box, confirm, and then after user does that, you can have full control of the device. And you can do some fun stuff with it. Example, throw down all the Samsung crap that they provided you. So, for example, Samsung Store, I'm not sure that this is the correct packaging, but anyways. You get system service, you get Enterprise Device Manager. That's just one of the servers that Samsung provides. IDE will warn you that this is not the correct screen, but that's because Samsung added a bunch of additional services that Android doesn't know about, and just ignore it. you get this back, you get application policy, check if you can delete this up, which you will be able unless the application is a device administrator. And if that's true, you can just delete it. So, cool way to get rid of a bunch of applications that you don't want. Yeah, and that's basically it. Similar flow that you see here will be for every feature that you want to use from Nox. Get a service, do stuff with that service. That's it. If you don't have permissions for that particular service, you will get security exception just like you would in Android. And if you need permission for it, you just add it into Android manifest file. The only difference that it won't be Android.permissions, it will be com.sensor.permission and something on. And yeah, that's it. You can do a bunch of fun stuff with it. In our project, we had the problem that caused us the most pain was when Samsung moved from old way of signing app to the new ELN process was CI. Because Samsung decided that they won't provide emulator, we asked them like, what should we do on CI? And they were like, oh, we didn't thought about that. So, first thing you can do is, of course, use real devices, but at the time we were running Travis, so we didn't have that option. So next thing we looked was device clouds. The latest we looked at was the Amazon one, but the problem with this is that device clouds don't allow you to use a device administrator because you can reboot the device and wipe everything, so they don't allow you to use it, so that wasn't an option for us. What we did at the end was, that was around the time that Android tools team provided the unit testing support. Around that time, we did a pretty similar solution to our problem. So basically, we took a jar that's in add-on part of the SDK, and you have two jars. They're not called Nox jar, but it's easier to remember. We took a jar, and basically that jar included the same as Android.jar, if anyone knows. You have all the methods that they provide, and every method just throws a runtime exception. This is for the reasons that you can have auto-completions in IDE and stuff like that. So basically what we did, we took that jar, removed all the final declarations from it, and instead of throwing runtime exceptions, we switched it with return null or 0 or stuff like that. And then when we run tests on our CI, we just add that dependency to it. And whenever you're working with Nox stuff, you always smoke it. And it has worked out pretty well for us. Basically, we can test everything that we want. Then we took it to the next step because no one wants a Samsung device. So there was a problem when a bunch of developers wanted to work and they have like Nexuses and stuff. They couldn't install on the device, so we created a mock variant that basically also includes this mock Nox jar and mocks all the things that we use in our application. We use Dagger, so this was pretty straightforward for us. And again, it was really useful, but you got to maintain it. So if you don't use it for like 2 months, you'll have a bunch of stuff to edit and that. So, but otherwise, yeah, it worked out for us. Yeah, that's pretty much it. Questions? No. portal that you can submit bugs to it. Then you submit a bug to it, you really try your best, write a long report, send it, and then you don't hear from them for 14 days, for example. Then they got you back, say they can't reproduce it, stuff like that. You go back and forth. Then they say, okay, it's fixed, it will be deployed in next version come, it's not fixed. So yeah. We had like 14 days ago, we had a situation where Samsung decided that they will, for every Galaxy device, basically, they will install battery optimizer for you. What that battery optimizer does is, if you haven't opened app for 3 days, which in our case happens because we have app that's in background basically and analyzes your traffic, stuff like that. And usually people don't open that app. So if user doesn't open that app for 3 days, they'll force close it. You won't get any notifications, all the pending intents will be closed and stuff. So we went to them like, what should we do? And they were just, yeah, just disable the app. Which, because we are using Nox, we can do. But we didn't want to do it. So at the end we did like schedule some alarms, and when device is on sleep we show up activity and close it, and it worked. Yeah, so they tried, but I think that their code is so messed up that they just can't handle it anymore. Any other questions?
How much does it cost to get the signing by Samsung?
Oh, I don't know. I don't have that information, sorry. But it's a really, really long process, and they will verify you in every possible way and stuff like that. So, but I'm not sure about the cost. Anyone else? Yeah.
Can you provide examples of some apps built with Nox?
Yeah, I guess I can. Basically, it was one that we're working on now for 3 years. It's called Wandera. Don't check the reviews on it, because the administrator puts it on the device and user can disable it. Yeah, that's the one, and what it's doing is setting up some APM proxies for you. We try to detect man-in-the-middle attacks. Basically, security and data optimization app. I guess check it out. Check Mandela.com website. It tells you can get much information there. But it's business-to-business app, so it's not for end customer. Anyone else? Cool. The whole Kamino Android team is here. They're wearing these nice t-shirts, so we'll stick around, and if anyone has any more questions, just ping us. Thanks.
Stick around.